right, ladies and gentlemen, this class recording has started. So, over the past 3 days, we have been talking about this idea of stoichiometry. Stoichiometry being quantitative relationships among reactants and products. So, right, we talked about that chemical reaction. We start with reactants, we end up with products, and we talked about identifying those reactants and products early on in this unit. We talked about where are the reactants, where are the products in the equation, etc., etc. This week, we've been talking about putting numbers onto that. So not just what are the reactants and products, but how much of each reactant or product do we have? If we start with a certain amount of reactant, how much product do we end up with? We said that one of the key features that helps us analyze that is the balanced chemical equation, specifically the coefficients of that balanced chemical equation. We use the coefficients of a balanced chemical equation to do what in our problem? Yes, but we said that they can also give for us the mole ratio, right? Comparing, relatively speaking, what ratio of reactants to products we need to make that reaction go. The first type of problem that we looked at was just converting moles of one thing into moles of something else. And we only needed one conversion factor, just the mole ratio. So it was a one-step problem. Yesterday, we started looking at what happens if I give you an amount of one of the reactants in grams. And we talked about how we can't compare grams of one thing to grams of something else, but we can compare moles to moles through the mole ratio. Because remember, moles is always the same number of items, right? They might not necessarily weigh the same, but we at least know we're comparing the same number of these to the number of those, right? And that was a two-step problem. The first thing we had to do was use the molar mass of something to convert that value into moles, then use the mole ratio to compare moles to moles. Okay? Good there? All right. Last type of problem is Roman numeral 4 on your outline that's on the back side, and it starts with this situation. So it says tin 2 fluoride, which is this compound right here. I should use some other color besides black so it shows up. Tin 2 fluoride is added to toothpaste to help prevent cavities. It is made by the single replacement reaction of tin with hydrogen monofluoride, which is that compound right there. How many grams of tin 2 fluoride are produced from 30 grams of hydrogen monofluoride? So, to start us off, here's what I want you guys to do. Let's take 2 minutes and discuss with the person next to you, and let's get this problem started. So the first thing we should do is what? What are they asking us for? The second thing we should do is? What do we know? What do we know has to include what? Balanced equation. All right? So, just so you guys know, right? Yeah, I'll save that for later. Okay? So 2 minutes. Work with the person next to you. What are we looking for? What do we know? Let's make sure that the what do we know part has a balanced equation. Go. All right, ladies and gentlemen, we are back. So, we talked about, and oh, by the way, just so you guys know, okay, this is what I was going to tell you beforehand, but I decided to wait until now. That little exercise right there, that is beyond what I would ask you to do on a test. Okay, I will not make you figure out the equation on the test. I just kind of wanted to see where you were, and okay. So I will give you the equation on the test. You just need to balance it. All right, but let's go through the process. So, first step of the process. Right? That's what we're looking for, right? How many grams of tin 2 fluoride? We know that we're starting with 30 grams of hydrogen monofluoride. Okay? Now, the hardest part here is coming up with the balanced equation. But it did give us a little bit of information. Right? First, it told us that it was a single replacement reaction of tin with hydrogen monofluoride. That's meaning that our two reactants in this problem are tin plus hydrogen fluoride. Okay? Now, in a single replacement reaction, right, we start with an element by itself and a compound, and then the element goes in and kicks something out of the compound. We know that this has to be one of the products, because that's what it tells us in the problem. So we know that this is one of our products, and that means what got kicked out of the compound? Hydrogen did. So there has to be hydrogen over here, but it's by itself. Now, the real key to doing this, and this is why I won't ask you to do this on a test, maybe you remember, maybe you don't, but hydrogen is one of our diatomic elements. So it doesn't end up like this, it ends up like this. Hydrogens get kicked out of hydrogen fluoride all the time by tin. But they don't just stay by themselves. They then find another hydrogen to join together, and the product of this equation is H2, not just H. But, so that's our equation to represent this single replacement reaction. But is this balanced? No. It's not, but it's pretty easy to balance. Okay, put a 2 right there, and then we're good. Like I said, that's beyond what I would ask you to do on the test, at least making the equation. I would expect you to be able to do this, and I would expect you to be able to do this, and I would expect you to be able to do that, the balancing part, but not make the equation yourself.
Are we going to need to write down that?
Not necessarily, no. As long as you, I'm not going to make you do it any specific way, but there's reasons why I'm taking you through these steps, because I think it will get you to the end easier. All right. So over the past couple days, we've talked about that stoichiometry problems are conversion problems, right? Ultimately, a conversion problem gets rid of a unit that we don't want and leaves us with a unit that we do want. So we're going to start glad that got on recording. So hope that gets picked up. So. All right, we're going to start with this, because we said that's what we're reacting tin with, and we want to know how much product we get. So, let's do units first. What unit has to be on the bottom of that conversion factor? Because remember, we got to cancel this and this, so we got to put them on opposite sides. Now, we said that conversion factors ultimately get rid of units we don't want and give us units that we do want. In this problem, it's asking us for grams of tin fluoride. But, can we compare grams of something to grams of something else? No. Right? It goes back to the what weighs more, a pound of rocks or a pound of feathers, right? They're both a pound, but that doesn't mean there's the same amount to them, right? So we can't do this problem with one step. Because, and right next to where you're doing it on your sheet, you have this awesome graphic that clearly shows you cannot go from grams of A to grams of B, right? Road closed. No, I don't know how to make it any more clear than this. I mean, so to Avon, easy. What's wrong with going to Avon? Oh yeah. That thing's been closed for like 15 years. I don't think they're opening it back up again. So. What, this? This is just a picture from another book that I took. So I didn't make that. No. That's a picture that I copied from another book. So. All right. So there is no direct road to get from grams of one to grams of the other. But we do have a path that we can follow, right? A little side road. So let's take that side road, and the first step of the side road is going from grams of A to moles of A. So going back to here, right? In this case, A is our hydrogen fluoride, what we're starting with. We need to get rid of grams, so that's why that went here, right? But we can do this. We can go grams of one thing to moles of that same thing, right? That's allowed. Okay? That's step number one on this detour. You can compare grams to moles as long as it's the same compound. Okay? That's allowed. Right? So that's step one of this detour. Right? Step two of this detour takes us from moles of A to moles of B. And as it's labeled right here, we do that with the mole ratio. So, right? Oh. Time sign fraction bar. So what unit has to go on the bottom of that mole ratio? Moles of HF has to go here. And then that has to go on the top. We can do, and so Jillian, like, as far as the difference here, right? We can go from one compound to another compound if we're comparing moles to moles. That's okay. Can't go grams to grams. That's, right? Oh, that's this, right? That's this road here. We can't do that. But now we've taken this first part of the detour, and now we're on the second part of the detour here, converting moles of A to moles of B, or in this case, moles of hydrogen fluoride to moles of tin fluoride. But we're not done yet, right? We haven't gotten to our destination. We have one last step on the detour, right? We have to convert moles of B into grams of B, or moles of tin fluoride into grams of tin fluoride. So, a third conversion factor. What unit has to go on the bottom of that conversion factor? Okay? So now, let's go this, right? Mathematically, right? Even though we don't have any numbers in here, let's make sure we get where we need to get to. Right? Remember, we can put that over 1 if we need to, right? Just turn into a fraction. Grams of HF on the top of a fraction here. Grams of HF on the bottom of a fraction here. What are they going to do? They're going to cancel. Moles of HF here. Moles of HF here. They're going to cancel. Moles of tin fluoride. Moles of tin fluoride. What's the only unit that we have left in this problem? Grams of tin fluoride, which is good because that's what we want, right? All right, now, numbers, okay? So, let's start with this one. This second conversion factor. Moles of hydrogen fluoride, moles of tin fluoride. That makes it our what? Mole ratio. And we get the numbers of the mole ratio from coefficients. So, there and there. Okay? All right. Now, let's talk about these two. We said we could compare we said we could compare grams of one thing to moles of that same compound by using the what? By using the molar mass. We get the molar mass by adding the numbers from the periodic table. Okay? Now, wait. The reason why I don't want to say adding the two together is because we're going to get to something in a second, right? So, here, right, this formula only has one hydrogen and one fluorine. So you go to the periodic table, right? You find the molar mass of hydrogen, you find the molar mass of fluorine, and you're going to add them together, and if I'm not mistaken, I believe it's 20.01. Is that correct? If you use a different periodic table, it's going to have a little different number, and that's okay. So, just like rounding usually. It depends on your periodic table, like how many decimal places does it show. It might round a little, you know. Okay. All right, but, and here's the important part. Okay? Here's the important part. This is the molar mass. That means it is the mass of what? 1 mole. Even though in our balanced equation there was a coefficient of 2 in front of hydrogen fluoride, that only shows up in the mole ratio. When we are converting grams into moles, if this is the molar mass, or the mass of 1 mole, 1 goes there. Even though we have a 2 coefficient in the balanced equation. That doesn't mean anything when we're doing grams to moles. Those coefficients only show up in the mole ratio. Okay? Good there? All right, now let's go over here. Last conversion factor, we have to convert moles of tin fluoride into grams of tin fluoride. We're going to use what to do that? The molar mass. The molar mass is the mass of 1 mole. So mole gets a 1. And then, so we get this number here from where? Periodic table. But fluorine, right? In this compound, there's 2 fluorines, but only 1 tin. So we have to add together the mass of 3 atoms in this case, right? 1 fluorine, 2 fluorines, 1 tin, and it's 156.71. All right, good there. Good. All right, then, mathematically, multiply the tops divided by the multiplication of the bottoms, and when you do that, you're going to end up with 117.4737, etc., etc. How many significant digits in this number that we started with? 4. And that means our answer has to have 4. So we would round that to 117.5
grams of tin.
So when you become a chemical engineer, you know how much stuff you're going to start with and how much stuff you're going to end with. Or, Alex, if you want something more practical, because it's going to be on your quiz next Friday. All right, hold on 1 second, please. Freeze just a second. All right, so the sheet that I gave you yesterday says Intro to Stoichiometry Problems, Mass-Mass Relationships. Mass-Mass relationships involve 3 conversion factors. The first conversion factor converts grams to moles. The second one converts moles to moles. And the third one converts moles to grams. That's a mass-mass problem. That's 3 steps, okay? This page has several examples of those types of mass-mass conversions. Now, I will tell you one thing. First, the answers to all of these problems are posted on the homework for tonight. Okay? You pop it up there. There's the answers. The second, and probably more important thing, as far as if you're going to try some of these, on question number 2 on this page, it says here, and I'll zoom in for you guys that are watching, okay? It gives you a description of the reaction, and you'll notice that on your page, there's actually, the product here is H2O. That's not the product of this reaction, okay? Because there's no oxygen over in the reactants. So get rid of the O at the end of that, and the product is just H2, of number 2 on that page, okay? All right, so answers are posted online. Tomorrow, you will need your book in class. You can share with the person next to you. You don't all need your book, but you will need a book, all right?